Welcome to day 19 of the 2024 Advent of Code. For today's problem, we have a bunch of towels that are marked with patterns of colored stripes and a bunch of designs that we want to piece together. We can't reverse patterns by flipping towels upside down because that will cause the logo to face the wrong way. So for the example, these are the patterns that we have and these are the designs we want to piece together, and we want to figure out how many designs are possible. The way we'll do this is, let's grab our input first. So we can get all of the lines as the entire input file split over lines, and then we can get the list of patterns from the first line split on commas. And then we can loop through the designs by looping through all of the lines skipping over the line containing the patterns as well as the extra blank line. And now we want to figure out if it's possible to get this design. So we can do this using a recursive function where we'll basically check the first couple of characters and see if any of them line up with any of the patterns. If so, we'll see if the rest of the design can be completed with the patterns as well. So this is what that'll look like. Rather than looping through each of the patterns, because there are a couple of hundred of them in the example, we can instead just loop through the first couple of characters in the design and see if that is in the patterns. We'll cap off how far we search by getting the maximum length of any pattern, which will allow us to call how many characters we look at in the design. And then we can do this. For I in range up to the max length, and then +1. And we can also limit this further by not looking farther than the length of the design. Because if we went up to max len and didn't do this, then we'd basically be slicing the design beyond where it already is, which isn't going to cause errors, but it'll just cause us to check the full design string multiple times, which is redundant. We also need to set up our recursion base case. So if the design is an empty string, then we're done and we can return true. And finally, if the first I characters of the design is in the set of patterns, then we can try the rest of the design. And if we can obtain the rest of the design as well, that means that we now have a way to take one towel and then some other number of towels and add them together to form the design, which means that we have a valid case. Now, if this isn't true, we can still potentially run into a different towel pattern that contained the first one we found as a subset, and maybe that will allow us to obtain it, so we need to keep looking through all of the possibilities. And then we can just do a simple counter. We could even do like just print some can obtain design for design in lines 2. Again, can obtain returns a boolean here, but in Python, booleans are the same as 1 and 0, so you can sum them up to get a count. Or if you want to be a bit more explicit, you can say like 1 if can obtain design, else 0. This is perhaps a bit more clear. We can see that this takes too long. No worries, we can simply import the cache function from functools again and just apply memoization to this. Basically what's happening is we're recomputing the answer for the same design multiple times. If you're not a fan of using built-ins, you can also do it this way. Like so, and then you can say like cache design equals true, return true, cache design equals false, return false. This would be how you would solve this problem using manual caching. The important thing is basically that you don't recompute the answer for a given substring, because future designs might contain parts of past designs within them. So I'm trying to see if we have a good example of this here. I'm not sure we have a great example of this here, but let's say, for example, we wanted to test like this, and then we also wanted to test this, sorry, and we also want to test this, then if we see that this string can be accomplished, then when we try this, we look at the first letter, we see, okay, there R is a pattern, so let's try the rest of it. And then we don't need to then go ahead and compute the many cases for this. Again, we can just look at our cache and see that we've already determined that it can be obtained. Just for simplicity's sake, though, I'm going to still use the functools caching. And that gives us our answer for part 1. For part 2, unsurprisingly, it's just how many different ways can we make each design and get the sum. That's also fairly straightforward. If the design is empty, we return 1. Otherwise, we can just do a count. If the first I characters of the design are in the patterns, then we can add all of the possible ways to make the rest of the design to our total count for making this design. And so basically it's just the sum across all of these. And so it's just count plus equals this, and then at the end we return the count. And let's rename this function to number of possibilities. And now our sum is no longer a if else, it's just sum up the number of possibilities for each design to get our answer for part 2. Thank you for watching today's video. I hope you enjoyed, and I'll see you again next time.